We solved last time systems of equations with two variables, right? And there was just an x and y. Was that pretty easy for everybody? Okay. Then today what we're doing is we're just going to take it up one level and we're going to solve a system of equations with three variables. So just a reminder, these are the steps we take to solve a system of equations with three variables. First, we're going to pick a variable to eliminate, and then we're going to make two different groups of equations. So you can set up two equations. It doesn't matter which two. You'll set up two different equations. Then you're going to eliminate the same variable in each. So let's say we chose to eliminate x. Then look, you'll have two new equations with just y's and z's. Does that make sense, everyone? So then at that point, you're just solving a system of equations with two variables. And then you just, from there, once you found the two variables, because you'll solve the system like with substitution or elimination like we did in the last lesson, then you'll just go and take and plug it back into either the top, bottom, or, sorry, top, middle, or bottom. Kind of ringing a bell maybe from 1010? Okay, let's do it. It doesn't matter which you choose, but it really doesn't matter. Which variable do you want to eliminate? It's just sometimes one variable would be easier. X is easiest? Okay, sure. And you're seeing negatives and positives. Is that maybe why you chose that? And then smallest number? Okay, cool. So I'm gonna write myself a note. I'm eliminating x. I'm eliminating x. So then I'm gonna pick two equations, top and middle. Sure. It doesn't matter which two, but I'm going with top and middle. So all right, and then I'm gonna pick the middle and bottom, but it doesn't matter, right? It really, really does not matter. So the only reason I'm choosing the top and middle and the middle and bottom is because they have opposite signs. But it would not matter if you didn't choose those two, like those two, if that makes sense. Okay, so now we're going to eliminate x in each of these. So notice, in this one we don't even have to manipulate the equation. It will just, if we add straight down, it's going to eliminate our x, isn't it? So adding straight down, those cancel out. And we get 1y, then it looks like plus 2z's equals 5. Alright, now look, we have a new equation with no x's. Now right here, this one's going to take some manipulation. We're getting rid of x, so we're going to times our top equation by 2. Distribute, 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 distribute. So that's negative 2x, and then it looks like we'll have plus 6y. Then plus 6z equals 7. Then we're going to add straight down. My x's are gone. Oh, why did I write 7? 8, okay? So then adding straight down. Yes.
Isn't it 7?
Oh, that's probably what, wait, 7z.
Because you multiply it and then you add yeah, then you add it.
Yeah, we haven't got there yet. So I'm now adding straight down. Oh, you're okay. So now we have 6y plus 3y, which is, sorry, 6y minus 3y, which is 3y, yeah? And then we have plus 7z's equals 18. Okay, now look at your two new equations. Now you're just on step 2. Take those two new equations, and now you're just solving a system with two variables. So we're on our second step. So I'm just going to do my work up here, though. I'm going to rewrite it. We have y plus 2z equals 5, and we also have the equation 3y plus 7z equals 18. So which variable now would you prefer? Okay, so we'll take and times the top one by, if you want to get rid of y, times by negative 3. So then we have negative 3y minus 6z equals negative 15. Adding straight down, we get 1z, don't we? Z equals 3. Now guys, we write answers as x, y, z points. So we just found our z value. So I'm going to go put in, we know z is 3. We don't know y and x yet, do we? Now think about it. Can't we go to our second step here and now solve for y? By plugging in the 3, I'm going to plug it into this one right here. So that's y plus 2 times z, which is 3, equals 5. So then I have y plus 6 equals 5, therefore y equals negative 1. So now I can fill that in there. And now all you have to do is go and plug those into an equation in our original problem. So I'll just go at the top. So we have x, we don't know, minus 2 times y, so minus 2 times negative 1, minus z, z is 3, and then equals 1. X plus 2 minus 3 equals 1. X minus 1 equals 1. So x equals 2. There's your x, y, z solution. Does that make sense, everybody? Pretty easy. It's kind of funny because in 1010 we thought it was so hard, and it's not. It seems easy now, huh? It's funny how much we like grow in just a short time. Okay, now also I just want to point out, I wish I had a picture up here. What you actually found is, like, okay, so this is an x, y, z. Some people might be interested. Okay, so it's like taking, if we were finding just x and y, it's like finding two lines where they intersect, right? But now, because we have a z, it's actually like three-dimensional, meaning like, for example, if I had a piece of paper, and then I cut another piece of paper through it, and then cut another piece of paper through it, 3 pieces of paper, that the intersection point, would be the solution set here. 2, -1, 3. So a z-axis is actually like, just so some people might be interested that are going to go on in math. What we just introduced was, when we do an XY chart, you guys, we're literally doing, this is flat math. Like, look down on the ground. This is X, Y. Now what Z does is, once we get to Z variables, we become three-dimensional math, like X, Y, Z. Do you see how that looks like the corner of a room? Now it's a three-dimensional, it's three-dimensional math. So the Z-axis is literally this axis. Does everybody kind of see what I'm saying? So yeah, just kind of interesting for those people that will go on in calculus. Calculus 2, you get into three-dimensional math, and it's kind of cool. Cool. Okay, so let's keep going. Let's do another one. Do you guys want to try solving this one by yourselves, and I'll just do it as well up here? Okay, cool. Go for it. I'm only going to have you, in first hour, everybody just kind of check their answer with mine, so everybody try it. But let's all choose the same variable to eliminate, at least, so that we can kind of check our answers together. Do you want to eliminate X, Y, or Z? Okay, whoever said Z is nutso. Just kidding, but really. That's the worst one. I would say Y's, you guys. Look how easy the Y's are. Aren't they already opposites? Exact opposite. Yeah, so I'm going to eliminate Y. Let's eliminate Y. Okay, you do it on your own, on your paper. Don't look up here till you get an answer. This one actually might need to answer. Are you guys trying this, or are you just talking and chatting out there? We chose to eliminate Y, so I paired two different equations together. It doesn't matter though, you can pick any two, but you can't do the same one twice, you know what I mean? So it really doesn't matter, but if you don't choose the same two as me, your equations won't be the same, but your solution will end up the same. I'm randomly choosing the top and middle, but like, it's not so random, I just saw that these were opposites, so I like conveniently chose them. But if I didn't choose those two, it wouldn't matter. Does that make sense?
Oh, okay, so you did the top and middle, and then the top and the bottom.
Right. Just a sec. But Dave, if you didn't use the same equations as me, you can't compare it to mine. You can compare it to my final answer, you just can't compare it to my work.
Yeah, I think that was what the equations are, because I have the same two legs, but then the same setup, I just don't know how to they're not added a five to two, so I don't expect to, yeah, I think those equations.
Okay, sweet. Checking your answer. All right, so you might be able to just watch this one because you'll see what ends up happening. The math is going to be pretty quick to where we see there is no solution. So pick a variable to eliminate. It really does not matter. And do you see any variables that maybe stand out to you personally? Y's, I agree. I think Y's stand out because there's 2's and 4's, you know what I mean? So I just feel like that's fine. There's not a right or wrong answer though, you know, you can eliminate whatever. So we're choosing to eliminate Y. Okay, eliminating Y. So this one is going to take some manipulation. Don't we need to times this by -1? So that would be negative x minus 2y plus 2z's equals -1. So let's add straight down. That's 1x, y's are gone, and then it looks like plus z equals 5, right? Okay. I'm eliminating y, so it looks like I need to times this by -2. So then we would have negative 2x minus 4y plus 4z's equals -2, adding straight down. So x, and then it looks like we have plus z equals 3. So now we put our two new equations together. Here they are. I'm just going to take this and write it down underneath here. So we have our x plus z equals 3. Now eliminate a variable. So x or z, it doesn't matter. X, sure. So we distribute. So that's negative x minus z equals -5. Add straight down. Well, notice in this problem, both variables happen to cancel out, don't they? So that's 0. 0 equals, add those up, -2. Does 0 equal -2? No, therefore you can't continue to solve because you got to the no solution point. So no solution. That's just what you would write. You would not be able to continue solving. If variables cancel out and you have a not true statement, no solution. Now the infinite ones are the ones that were a little bit harder for people in 1010, so everybody focus. Hardcore focus. Now understand, with these systems, if you're not getting a correct answer, I'm not going to be able to look at your work and tell you where you went wrong. It is too much. You could have made an error anywhere from the start to end. So if you get a problem wrong and you kind of look back over your work and can't see where, you got to just start over and go extra careful. All right. You're going to see, I would write this one down for myself because this is the one with infinite solutions, and we have to write our answer in a very specific way. Okay. So we have these three equations. We're going to choose a variable to eliminate. In my opinion, I'm almost feeling like either x or y. So I heard a lot of people say y. So, I mean, the first part I think we probably get pretty well. It's the answer on this one that's interesting. And then the bottom one. Okay, here we go. Getting rid of y. Oh, getting rid of y? I like it. So then our y's are already exact opposites, so if we add straight down, we're going to get 3x plus 9z's, aren't we? Equals 0. There's our first true statement. Then here we're going to need some manipulation. We're going to have to times by 4 here so that they're opposites. So that's 4x minus 4y plus 20z's equals -8. So we add straight down and we get 6x minus 18z's. Oh, no, wait, it's plus 18z's, isn't it? plus 18z's, is equal to 0. So now let's put our two equations together. So I'm just going to take this one and write it underneath this one if you don't mind. So 6x plus 18z equals 0. Now you'd say I'm going to eliminate x or z, one of the two. So let's go with x, sure. So we times this by negative 2. So then we would get negative 6x minus 18z equals 0. Remember that 0 times negative 2 is not negative 2, it's 0. Add straight down. Well, once again, our variables all happen to cancel out, but this time it's 0 equals 0. That is a true statement. Therefore, our solution is all real numbers, but it's all real numbers. Remember what I said, this is like 3 pieces of paper being intersected. Now remember, if we have infinite solutions, yes, it's infinite solutions, but it's infinite solutions on the paper. Does that make sense? It's like the paper on top of the paper on top of the paper. Just like the line on top of the line when we have two variables. So we have to write this as our answer as a specific way. So remember our answers go like this. X, Y, Z. Now what you're going to do is you're going to look back to your system of equations where you had two variables. You're going to choose a variable to leave as the original variable. So X is X or Z is Z. It doesn't really matter. So there are going to be multiple ways we can write the correct answer. So let's choose to leave X as X because it kind of feels natural. Do you agree? So I'm going to underline here. In my solution, X gets to stay X. But now these two can't have Y's and Z's. They have to have only X's. So what we're going to do is go back to the two variables and we're going to get it into Z equals form. Because then we can replace our Z with Z equals a function in terms of X. So you can pick the top or bottom. They'll both simplify to be the same thing. It doesn't matter. So I'm choosing this top equation right here in my two variables. So my true statement right now is this. 3x plus 9z equals 0. Does everybody see what I'm doing? Now we need to get z all by itself because then we can replace that z with what this z is. So get z all by itself. Subtract 3x from both sides. So now my true statement is 9z is equal to negative 3x. Divide by 9. So z is equivalent to negative 1/3 x, isn't it? So now what you can do is go back to your equation and say, okay, so x gets to stay x. We still don't know what y is, but z is negative 1/3 x's. So now all we have to do is now instead of a y, we need it to be in terms of x. So now we're going to go back and plug those in to any of the top equations. Now guys, look, x gets to stay x. I'm going to do it for the top one. But now z is that, isn't it? And then we'll be able to solve for y. So I'm going to do my work right here. So x is x. So we have x minus y plus 5 times z. Isn't z negative 1/3 x? And then that's equal to negative 2. So now from here, guys, I'm going to start simplifying this. So now, everybody look, we multiply fractions straight across. So I have x minus y, and I have minus 5/3 x. Does everybody see how I'm getting that? Equals negative 2. Now look, how do I combine 1x minus 5/3 x? Isn't it just 1 minus 5/3? They're like terms. So I'm going to do the math right here because I have room. 1 minus 5/3. I would have to get a common denominator because my calculator can't give me answers. So that would be 3/3 minus 5/3, which is negative 2/3. So when we combine our x's, we have negative 2/3 x. So I still have negative y. Now I have minus 2/3 x equals negative 2. So now get y equals alone. We need y all by itself. Yep, so add this over. So now I have this true statement. Negative y is equal to positive 2/3 x minus 2. Then we'll divide both sides by negative 1. So we know that y is equal to negative 2/3 x plus 2. So now our final answer is x is x, but y is negative 2/3 x plus 2. And z is negative 1/3 x. So we have it all in terms of x. Now here's the thing, guys. If you would have chose to, back to our two equations, if you would have said let's leave z as z, this would be a z right here, right? You'd have a z, then you'd rewrite the other, x would be in terms of z, right? And then this would also be in terms of z. So it doesn't matter. So keep in mind, if you, in the back of the book, if you have an infinite solution set, and they choose a different variable than you, you're not going to have the same answer as the back. But I have to accept there are, in this scenario, there were 2 different solutions. I mean, there's technically 3 different ways I could write this as an infinite solution. Because what if I would have chose y as y? Do you guys kind of see what I'm saying? On the test, I'll accept any of the above. Now, here's the thing. Sometimes when you choose a variable, you start simplifying for the other variables, and it's like nasty, huge fractions. If that happens, go try the other variable, because it's usually just that you kind of picked the uglier variable. Does that make sense to keep? So say, okay, instead of x, I'll try to see if I keep z if the things come out prettier. All right, awesome. Okay, that is the only infinite solution one we're going to do. So last one is this story problem right here. It's pretty straightforward stuff, actually, the story problems on these ones. So it says, Jason receives an inheritance of $50,000. His mom suggests that he invest that money into 3 mutual funds: money market fund, blue chip stock fund, and high tech fund. His mom estimates that the money market will earn 5% return over the next year. Blue chip will earn 9%, high tech will earn 16% return. Jason wants to earn $4,000 within the next year. To avoid excessive risk, he does decide to invest 3 times as much money in the, 3 times as much in the money market fund as the high tech fund. How much should he invest in each? So we're going to have to set up a true statement. Now guys, from here, we have 3 variables. So isn't it true, like let's write out, x is the amount of money he's going to put in money market fund? Isn't he going to put an amount in money market? So let's call y an amount he's going to put in blue chip, and then z is the amount he's going to invest in high tech. Okay, cool. So now, because there's 3 variables, there should be 3 true statements in this story problem. Can anyone tell me one true statement? Okay, so you're saying that x needs to be equal to 3 times the amount he's putting into the high-tech fund? Does everybody see how that would be a true statement? Okay, that's our first true statement. Second, another true statement. They're pretty obvious in this one. So you're going to do what? You guys think, it's like really not that big, it's really, like it's not any in-depth like brain surgery or review problem. No.
Well, 50,000 equals x plus y plus 1.
So you're saying that the amount x plus the amount y plus the amount z is going to be 50,000? True. So now we're dealing with percents, right?
Yeah,
now you're doing the percents. Well, isn't that going to be the, and like, that will have to do with the amount he earns, correct? Perfect. Okay, so, yep, so what would you write for, sorry, tell me one more time.
So it'd be like 0.05x.
Okay, 0.05x.
Plus 0.09y.
Yep.
Plus 0.16z.
Yep, and he wanted that to come out to be $4,000, correct?
54,000 or?
No, because right here we're not doing 1.05. If we did, that would be 100% back plus. Does that make sense? If we put a 1 in front of these, then we would need to add up, but this is just amount. Good question though. Okay, so then from here, guys, you would just solve by the same steps we just took. I'm not going to go through and solve this. Is that okay?
So why is it x equal 3z?
Because it said right here that he wants to invest 3 times as much money in in the market fund as he would in the high tech fund. So if you like thought about that, you'd say, okay, so if let's say he invested $20, then in x there would be 3 times 20. Does that make sense? Which that would be 3 times the amount in this as he put into this. Yes.
See what we were just doing in the third equation also?
These are 3 equations here. So I would just substitute. Like I would take this and I would plug that in wherever there's an x. I'm going to put a 3z, and then same down here. And then don't you have all equations with y's and z's only? Personally, I would do that. Okay. Okay, so the only last thing I want to point out is people I remember in 1010 specifically people freaking out in this instance. I'm not going to solve it. I'm just going to point something out. Do you guys see how you have 3 equations here? Same as usual. Now if I said solve, the first step we do is pick a variable to eliminate. Guys, you need to eliminate x. Why? Because that second equation already has x eliminated, doesn't it? So you'd say, okay, I'm going to eliminate x. Now look, when you pick 2 equations, this equation already has x eliminated. You don't even have to do the math to eliminate x. It's already eliminated for you. There's your first equation. Do you guys see? Then you go, okay, I need to eliminate x, so what other 2 equations do I have? Top and bottom. So you'd put x plus 3y minus z equals 1, and then you'd put negative 2x plus 4y plus z equals negative 1, and then eliminate x. And then you'll have 2 equations with only y's and z's. Okay? So if it's already eliminated for you, that's great. It's done one of the steps for you. I remember people being like, well, what do I do? Nothing. There's no math involved. It's already eliminated for you. Okay, cool. All right, that's the end of the lesson. So the rest of the time is homework. Please, you should get a lot done in class today.